Good evening, everyone, and welcome to Group 9 of Heat Transfer Project from Semester 2, 2021-2022. So before we get started, let us introduce ourselves. My name is Sherfi Salsabila, and you can call me Sophie. Here we have Divagar and also Zaim as my teammates. Okay, so moving on, table of content for this whole presentation. 1, we're going to start off with introduction. 2, calculation of the heat analysis. Number 3 is the design selection of the whole container compartment. 4, discussion and conclusion of this whole project. And moving on to the last is task distribution of the project throughout. So without further ado, let us start with introduction. As you all know, heat transfer is a basic science that deals with rate energy transfer in the form of heat. This project will allow us to practice the basic concepts and introduce the various modes of heat transfer, as well as thermal properties of materials. So as you know, heat transfer is divided into 4 sections, which is sublimation, radiation, conduction, and convection. So within this project, we're going to focus more about the sublimation of the dry ice within the compartment. And the task assignment itself requires us to propose a design of a refrigerated container truck to carry frozen food from a warehouse to a hypermarket with specific requirements. Those requirements set are the time lapse between the destination and also the starting point, as well as the dimension of the container. So apart from that, any other requirements that is provided within this project is assumptions that we have made from our own. So without further ado, let me pass this over to Zaim so he can explain about the heat analysis of this project.
Assalamualaikum and hi everyone. First of all, before we start our calculation, we should make a few assumptions in this calculation. First, throughout the entire 5-hour journey, the outside temperature remains constant at 40 degrees Celsius. Second, there is no heat loss during the process of placing the dry ice into the container. Third one, initial temperature inside of the container is at room temperature, which is 25 degrees Celsius. So we have to include the calculation of dry ice needed to cool it to the required temperature, which is -5 degrees Celsius. Fourth, frozen food heat release is neglected. And lastly, fluid velocity inside of the container is neglected due to enclosed space. From research that has been made, these containers body were designed in 3 layers, which are inside steel layer, middle layer, and outer layer steel. Inside and outside layer will have the same material and thickness, which are aluminum alloy 6111, which is commonly used worldwide. The thickness of each layer is 8 mm. In order to get the most suitable inside layer, we compare 3 materials that has high value of moisture resistance, which are cellular gas, glass fiber, and also commonly known as fiberglass, and lastly polystyrene. In order to get the heat transfer rate of the body of the container, we divide this calculation into few parts. As you can see, side walls, roof, door, and floor. Then we sum up all of this heat transfer rate to get the total heat transfer of this container. From the result of the calculation, we can see the fiberglass has the lowest heat transfer rate. Thus, we agree to use fiberglass as our middle layer. Moreover, fiberglass is famously known for its moisture resistance. Then we calculate the amount of dry ice needed and their price. In order to get that, first we calculate the internal volume of the container. After that, we calculate the mass of dry ice needed for the entire journey. This calculation is sum of 2 calculations, which are mass of dry ice required to cool the empty container from 25 degrees Celsius to -5 degrees Celsius, and mass of dry ice required to last for the entire journey. Lastly, by only multiply the mass of dry ice with the price per kilogram, we can obtain the price of the dry ice, which resulted to Rm 455 ringgit. Next, we calculate the required size of the dry ice compartment in the container. as we found that the size of 1 kg dry ice is 25 centimeter height, 21 centimeter length, and 12.5 centimeter width, the size required for one dry ice pack is 6.5625 times 10 power of -4 meter cube. Thus, the space needed for 70 kilogram dry ice is 0.04594 meter cube. We designed a dry ice compartment by putting a grill in the container that located 5 cm above the floor and 5 cm under the roof of the container. From this, we obtained 0.253 meter cube space. From this value, the dry ice compartment designed by us have enough space to store 70 kilo dry ice that can keep the container cool for this 5-hour journey. Thank you.
All right, so moving on to the design selection of our dry ice compartment within the container. As you all know, we've been given requirements for the dimensions of this container, which is, if you see here, 5.5 meters in length, 2.3 meters in width, and also 2.5 meters in height. And this is the 2D print of the container with dry ice compartment, which here you have the top view, side view, and also the front view. So if you're wondering where we place the dry ice compartment within the container, let me move forward. Here, I'll just give you a whole diagram of the exterior view. And then coming into the interior view, if you look closely, and I'll give you a zoom in view of this interior design, you can see there are bars and slabs, as you can call shelves of stainless steel placed on the bottom and on the top of this container. And if you're wondering what that is basically our design of dry ice compartment. So to summarize, the dry ice that we've chosen are dry ice slabs, which is basically a rectangular cuboid shape that is almost flat. So within this design, you could easily fit it in and also fit it out, slip it out if there's any access after the journey. And with this design, it also allows feasibility of any personnel to go in, to go out, whether they want to run, whether they want to jump on it, everything would be good still. And any products that you want to put inside, whether it's small or big, can be easily accessed. So with that said, this basically concludes the design of our dry ice compartment within the container. And in terms of heat analysis itself, our team has concluded and came to a summary that any dry ice that is placed in the middle of the top and bottom can be easily sublimated throughout and also give a longer cooling effect for the products inside throughout the whole journey. So that's about it. And without further ado, I'll just pass this over to Devagar to explain about discussion and conclusion of our project.
So in terms of the material, we chose aluminium and fiberglass. This is due to its durability, ease of installation, and based on the calculation, its superior application for refrigeration. In terms of the dry ice compartment, we mutually agreed to place it at the top and the bottom part of the container. This is to ensure that it is not blocked when loading and unloading of the frozen food. And at the same time, throughout the journey, we will have a uniform temperature. In terms of the mass of dry ice required, we found that it is lower than calculated because our container has low amount of heat dissipated. And in terms of sustainability, dry ice is way better than conventional ice. This is because conventional ice, when it melts, there's water, and we fear that this water will contaminate the frozen food. Unlike dry ice, it won't leave any residual behind. As a conclusion, we found out and we finalized our design, and it has met all objectives in terms of the result. It is almost acceptable or very close to accepting it in the reality. And also we found that SolidWorks knowledge is really useful for us engineers. That will be all from me. Thank you.
Okay, so thank you, Devagar, for your lovely share in the discussion. Let's move on to the last session of the presentation, which is task distribution. Now, in a team of 3, which is Zaim, Devagar, and myself, we were divided into 9 tasks, which is introduction, heat transfer analysis, compartment design, findings, discussion, conclusion, references, appendices, and also slide presentation. And despite the ticks that you see here on screen, we did complete each of our own individual tasks, but if anyone ever did find any trouble, then we would do our best best to help each other out. So starting with introduction, it was mainly done by Divagar. Heat transfer analysis was done by Zaim. Findings, discussion, and conclusion was done by myself. But for compartment design, compartment design, references, appendices, and slide presentation, it was done by the three of us. So moving on to the whole timeline, now the project briefing and planning, distribution of tasks, and also the introduction was completed within the first week of the project given. But as for compartment design and heat transfer analysis, it was done with the longest period of time within this project. And the remaining finding, discussion, conclusion, appendices, final report, and and slide presentation, it was done towards the end of the whole project. But as for the live meeting checkpoints, it was done within the beginning and also the end of the project. So that concludes the whole presentation for today. And we apologize if there were any mistakes. We thank you for your time and attention, and we hope you have a great day. Thank you.